Here it says explain why f of x equals 5 to the power of x minus 2 is an exponential function. For any exponential function, we say base is constant and the power we see variable. So variable appears in the exponent. So it's the reason we call it exponential function. The variable appears in the exponent. So it's the reason we call it exponential function. Part B asks what transformation can be applied to y equals 5 to the power of x to obtain y equals f of x. That means y equals 5 to the power of x minus a. We say if I have a to the power of x, then I can translate this function to the left side or right side. It depends of k that add up this exponential function. X minus k. I keep this minus and say if k is larger than positive, so move k unit to the right side, and if k is less than 0, so if k is larger than 0, once I say larger than 0, and if k is less than 0. K is larger than 0, the a to the power of x will move to the right side k units, and if k is less than 0, will move to the left side k units. Here, x minus k. K is 2, and 2 is larger than 0, so translate. I say translate 2 units to the right side. 2 units to the right side. Now for part C, it says sketch the graphs of y equals 5 to the power of x and y equals f of x, which is 5 to the power of x minus 2 on the same set of x's. So first I will go for 5 to the power of x. As input, I get x from -3, -2, -1, 0, 1, 2, 3. So it would be 1 over 125, my output. If I say 5 to the power of -3, 5 to the power of -2 gives me 25. 1 over 25. 5 to the power of -2 gives me 1 over 25. 5 to the power of -1 gives me 1 over 5. 5 to the power of 0, 1. 5 to the power of 1, 5. And to the power of 2, 25. To the power of 3, 125. We see my base is larger than 1, which is 5. So the function is increasing. Now here for the y equals f of x, if I put -3, -2, -1, 0, 1, 2, 3. If I put -3, so it would be 5 to the power of -5, which is 1 over 5 to the power of 5, and -2, which is 1 over 5 to the power of 4. Here, 1 over 25, 1 over here for -1, 1 over 125, for 0, 1 over 25, for 1, which is 1 over 5, and for 2 would be 1, for 3 would be 5. If we look at this pattern, we see exactly it's like I move the graph 2 units to the right side. Let me use technology to show two graphs and compare them with each other. Now in this graph, first of all, I start to draw y equals 5 to the power of x. So if I graph it and enlarge it a little more, we will see for 0 it equals 1, and for 1 equals 5. For 2 it equals 25. That I will go up here is a graph of y equals 5 to the power of x. Now I want to show that y equals 5 to the power of x minus 2. It's exactly same, but it moves 2 units to the right side. So if I show it, we will see. Let me enlarge it again. Look here for 2, I have output equals 1, and for 3 my output would be 5. So I can say 2 units, it comes to the right side. 2 units, any output comes to the right side, 2 units. So the k here, if k is larger than 0, move the initial exponential function k unit to the right side, and if k is less than 0, move the initial function k unit to the left side. But here k is positive, and so move the initial function 2 units to the right.